Hello, everyone, and this is our first online lab session. We are talking about cardiovascular system, the heart, blood typing, and vessels. We're going to talk about blood typing first. I'm going to talk to you a little bit about why we do blood typing, why it's important, and then we'll show you a video about blood typing using the patients that we normally would in our class. And I'll give you some instructions on a separate page in this folder, basically the instructions for the lab. You will take the data that you collect out of this and use it to fill up part of the information on the worksheet. You will then complete all of the questions that exist on the worksheet. And there's some material to read when you go through the worksheet as well. Blood groups and blood transfusions. We can make our own blood, and generally that's just fine for day-to-day stuff. We are constantly making a little bit. Not a huge amount. Maybe a drop every couple of minutes, And so if we lose blood faster than we can make it, then we've got a problem. If you have large losses of blood, what can occur is that you can get weakness. 15 to 20, 30%, you're just going to feel weak. When we look at how much blood that is, we've got about 5 liters, maybe 6. So we've got between 10 and 12 pints, ballpark figure. So if you were to lose, say, 1.5 pints, 2 pints, you'd start to feel a little weak. 3 pints, you might start getting in some, or being really weak and maybe getting in some trouble. Thing is, if you lose 30%, which would be 3 to 4 pints, then you get shock. And what's going on with shock is that you have lost so much blood that the body can't carry oxygen at the needed levels to all parts of the body. So what it starts doing is prioritizing, and it shuts off blood flow to certain organs. Digestive tract kind of shuts down, the kidneys may shut down, and so forth. Those are not critical short term to keep you alive. Long term, yes, if you don't replace the blood, you can have damage to those organs. You can even die as a result. Now, the only way that we can replace blood quickly is through a transfusion. That is taking blood that has been stored somewhere and putting it into the system. So we can use other people's blood, much like we can do when we are doing a organ transplant. And just like an organ transplant, transfused blood has to be of a compatible group. When you do an organ transplant, they talk about a match, and that is something that will trick our immune system into believing it's ours rather than someone else's. We have this thing, major histocompatibility complex, that's on all of the cells of our body, which our immune system uses to determine whether something belongs to us or not. And if it doesn't match up, it's going to get rejected. So with a really close match in terms of an organ transplant, I think the average is around 7 to 8 years before the body recognizes it doesn't belong to you and starts to reject it. With blood, fortunately, it doesn't have to be that long. Blood cells only last about 120 days. So 120 days after you've gotten a transfusion, you've got completely new blood. The cells aren't there anymore. So we just have to trick the immune system for a little bit. And that's made a little bit easier because the stuff that makes the histocompatibility complex on blood cells is a little bit simpler than other cells. What we have are some antigens that are on the surfaces of our cells. That's part of that major histocompatibility complex. We have antigens on our blood cells as well. And there's about 30 different antigens that come into play in terms of determining the characteristics of your blood. Antigens are things that the body recognizes as being foreign or belonging to us. And the things that we use to recognize these are antibodies. And if they come upon an antigen that they recognize, they will bind to it and cause a reaction to occur. With blood typing, we get to use certain antibodies to see if there's a reaction to certain antigens, and we can use that to determine what kind of blood a person has. So, like I said, there's about 30 of these things, but there's really only three that cause us big problems in terms of blood transfusion reactions. That is the A antigen, the B antigen, and really I should put down in here the RH antigen as well. Some refer to it as the D antigen. But in any case, those things are the things that can really, whether or not a person will reject a blood type or not. Now, the others can come into play. So even if we have the right type of blood, we still like to just double check. There's something called the type and cross, where you take a little bit of the donor's blood, a little bit of the recipient blood, mix them together and see if anything happens. We've got these three different antigens. We have A, we have B, and if a person has both A and B on their cells, then that is called type AB blood. If a person has just type A, that's type A blood. If they just have type B, that's type B blood. If they don't have either, that's known as type O. And we'll talk about the genetics of this in just a few minutes. But looking at this, basically, our blood cells are kind of funky in that we have in the blood plasma antibodies against the opposite type of blood. Now, most of the time, you have to be exposed to something to develop antibodies. So, if you get chickenpox when you're a kid, you'll have it one time. You'll go through the full 10, 12-day course of that, and then you'll get better. But now your body recognizes what chickenpox is, and it makes antibodies against it. So, when you're exposed later on, you don't get sick again. Well, with blood, it's a little bit different in that we have exactly the opposite type of antibodies as we have antigens. So if I had type A blood, I couldn't have type A antibodies or it would react to my own cells. But I automatically have type B antibodies. Now, the same token, if I have type B, and then I'm going to have type A antibodies. Now, what that breaks down to is someone with type AB blood, they cannot have either A or B antibodies. So they're not likely to react. Someone with type O blood doesn't have antigens, but they have both antibody types. So they would have both A and B antibodies. And it's this interaction between the antibodies that are in the plasma and the antigens that are on the cells that determine what you can receive. So someone with type AB blood can receive type A blood because they're not going to have antibodies against type A. They can receive type AB because they're not going to have any antibodies. They're going to type B again, and type O. So type AB blood is considered the universal recipient. Now, type B blood can receive both B and O. Type A blood can receive type A and O, and type O blood can only receive type O. But they can give to anybody else. So type O is considered the universal donor. With that, you would think having type O blood would be really bad, because the gene that gives you type O is actually a recessive gene. And typically, in populations, recessive genes don't show up as often. In fact, we would see this, we would expect, in about 25% of the population. But instead, what we find is that type AB blood makes up only 4 to 5% of the population. So if you have type AB blood, that's great for you, because you can walk into any hospital and you can get, they'll have the blood supply that you need. Type B blood, that's somewhere around 11 to 27% of the population. Type A blood, 40 to 28, something along that lines. But type O, oddly enough, even though it is a recessive gene, or it shows up in 45, 49, up to 80% of the population, just depending on ethnicity. There is another factor that I mentioned before. It's called the RH factor. And you can either have the RH factor or not have the RH factor. It is named for rhesus monkeys, which is where it was first found. And honestly, most people have the RH factor, about 90%. 10% of the people don't. So again, if you have the RH antigen, you can't have an antibody to that. But if you don't have it, you can make antibodies to it. And this time, antibody production is closer to what we see in a disease state. You will develop antibodies upon exposure to the RH factor. So someone who is RH negative will not have any antibodies to the RH factor until they've already been exposed to it one time. After that, they will be making antibodies. And that is an issue when we start looking at childbirth. This specifically becomes a problem when you have an RH negative mother and a RH positive baby. And again, the RH negative is recessive. So if the dad has given the mom the RH positive gene, or given the baby the gene for RH positive, then you'll have an RH positive baby. Now, so you've got an RH negative mom. Red blood cells don't cross the placental barrier, so mom's not exposed to baby's blood through the pregnancy. That's great. She's not going to make antibodies against it. Childbirth is messy. So they tell me. So at that point, you've got mom's placenta, baby's placenta. They're kind of interwoven, and they pull apart. And some of baby's blood gets into mom's bloodstream. When that happens, mom's immune system sees these RH positive blood cells, and they just go kind of, what? This is new. I'm going to make antibodies against it. You wouldn't think that that would be a problem. Blood doesn't cross the placental barrier, but the thing is, antibodies do. And if you're a mom, you may be aware that your baby doesn't get sick right away. Baby's born, it goes a few weeks before it starts beginning to get snotty, poopy, nasty. And during that time, what's going on is that during the pregnancy, antibodies that you make against everything that you've ever been exposed to cross the placental barrier, get into baby's blood, and protect the baby as well.